avoid greenwashing. David, thank you for closing us out today.
Thanks. Thank you all that you joined this conference, very focused. I'm really surprised about the content, that it's so deep, and it's not easy to add something after all the presentations. But however, I will try to do some interesting points for you. So the idea of this presentation is to drive the data center industry for new solutions, the decarbonised solutions. And as you've seen, and previous presentation was focused on the energy, and from this presentation, you understand that the grid itself goes to the renewables, and if you will even make nothing, energy which is come from the grid already decarbonized. So this top of the iceberg is already done. And our focus should be now on the things which is hidden, which is in scope 3. That means that we should focus on not only our infrastructure, I mean that's infrastructure, but also on the customers. So we create open source solutions on all stages, starting from the server, rack, facility, and ecosystem design. That customer, industry, all of participants can take that, evaluate, use, improve, and give back. So in collaboration, we're going to innovation. It's important to understand that software application define the hardware, the server. The server define the cooling method. Is it air cooling, or is it 8 kilowatt server which need on-chip cooling or immersion? And cooling method define the facility. And facility is also connected to the location. Is it Abu Dhabi or is it Oslo? And depends from that, you choose the cooling system. But also, if you make even heat reuse, you should understand what temperature you need to achieve. Is it 70 degrees? Is it 30 degrees? It's also impact on the facility design. And this is why it's important to think big. Now, why it's important to think about circularity? If you will take just one rack, in that center you need 3 square meters. If we take assumption that 1 square meter is 1 ton embedded carbon, so for one rack we need 3 ton embedded carbon of building, just shell and core. But the rack with 30 servers, embedded carbon is 40 ton CO2 emissions. Now let's look on the life cycle. The building life cycle is 30 years, but the rack with the servers is 3 years. And during 30 years, embedded carbon of the shell and core will be 3 tons, and the IT equipment, 400 tons. So 3 and 40. And if you focus your attempts to reduce this 3 tons by 50%, you will get savings 1.5. And if you will increase the lifetime from 3 years to 6 years, the carbon of the IT equipment will drop down from 400 to 200. This is why it's important to think big and take this comprehensive approach. So in this slide, I just showing that there is air-cooled servers. They can be refurbished, shift to the on-chip cooling, increase density, and give them second life and extend their life to the 6, 9 years by using different applications and owners. So now about the rack design. When you're shifting from air-cooled to liquid-cooled, you should explain how to do that, what we will achieve. In that case, we show that we can make low-profile liquid-cooled servers and achieve much more density, but with the same servers. And this is how we can achieve more efficiency. Just if we think about the impact of the metal rack itself, the embedded carbon of the metal racks is compared with all automotive industry which use the same metal. So, and if we reduce the quantity of these metal racks 2, 3, 4 times, we reduce that huge embedded carbon of the metal in the racks. Now about modular data center design. It's a way how to compare apple to apples. So we have the same form factor of the container modular data center, and conventional air-cooled data centers, modular, they are able to handle 90 kilowatt. And the limits there is air coolers inside of between the racks, indoor coolers. So with open source approach, we can show that liquid cooled hybrid cooled racks with liquid cooling and rear door heat exchangers are able to fit in one rack 62 kilowatt. From this 62 kilowatt is 14 air cooled, which is not issue, and 48 kilowatt is liquid cooled. So 62 kilowatt by 16 racks give you 994 kilowatt, 1 megawatt. And we just show that even for AI, we are able to make low embedded carbon solutions. But to achieve the same with the air-cooled, just air-cooled, we should use 11, 20 times more containers with all the equipment which come with that. And also that approach gives you possibility to go to the right place, install that modular data centers close to the heat user, close to the edge, so you fit for many requirements of the edge data centers. However, what about big data centers? What Christian said that we have a lot of heat, but there is no request for that. How to fit, how to go to the center of Berlin, how to go to the center of Paris, how it's possible to do, how it's create that conditions. And for that, I will give answer after these slides. So linear carbon economy, when we take renewable power, provide it to the data center and reject to the environment, the heat. And at the same time, in parallel, we burn gas by district heating operators and provide heating for the different heat users. So when we shift to the circular decarbonized economy, we shift heat rejection from the IT equipment to the our customers and reduce heavily fossil fuel consumption. And this is how it looks. This is the circularity of energy. And we also have open source ecosystem design. So open source fish farming, greenhouses, the integration and implementation. And another solution is water desalination, which is really power hungry, and installation starts from 10 megawatts, 20 megawatts, 30 megawatts, and it's fit by its duration. So desalination you can make around a year, and as the heat rejection from the data centers, and especially in Middle East and Africa. So this is also an important point, that how you can go to the hot country and all energy convert to the valuable product, and also cover the social aspects. And this is the one of the example of modular data center with 2,500 racks, which can be implemented in a city center and cover few things. First thing is that you provide these megawatts exactly where is needed. And when you are close to the city, it means that you don't have energy losses to the transport that hot water. You don't have to bring 90 degrees. You can reduce the temperature because you are much closer to the houses, and you can provide for 70 degrees. And that approach included in itself that you were able to put all the racks 100% air cooled, use heat pumps to achieve 70 degrees. After that, you can shift to the liquid cooling and have 50% air cooled, 50% liquid cooled by using the same heat exchangers, same piping, same pumps. So it's a flexible system. And also you are able to shift to 100% liquid cooling with the same infrastructure. So it's important to create the data center which are flexible by shifting from the air cooling to the liquid cooling. And this is also open source. So that gives opportunity to comes right to the city centers. And this is all what I want to deliver to you. So thank you for your attention, and I will be happy to answer all the questions.